So this is the communication area through which we are going to send data across programs. We send data for some working storage data. What we do, we send through COM area. In the receiving program, I mean the subprogram, what we do, we receive through linkage section. Same way whatever you did in batch. So here in main program, what we do, we send data through communication area. In a subprogram, what we do, we receive data through linkage section. Okay, I'll write the code and show you. Don't worry, I'll write the code. I'm going to write a small program today and I'll show you. You'll be writing a similar program today. Probably you'll be writing yesterday you created tax calculator, right? You can use the same map and we can do tax calculation. Okay, these are the only copybooks required. There are one or more copybook for advanced CICS. I'm just leaving that. For now, this is more than enough. Here, as far as DFHEABLK is concerned, system will be defined. System defines automatically. So need not define. User need not define. User should define what? User should define the symbolic map. System is going to define the EAB response. I mean DFHEABLK, DFHAID. User define. Did I tell what is the full form of DFHAID? I didn't tell, right? Data facility holder attention identifier. So data facility holder attention identifier. So what is attention identifier? We call the keys which is pressed by keyboard is a attention identifier. Okay. Even you might be creating a lot of mischievous things in your home to make sure your mom is giving attention. Right. Similarly, Ari does a lot of things to make people to give attention. Similarly, user will be using keyboard stroke to give attention to the program. So these are commands. These are copybooks that are required. So to start the program. Okay, you need a symbolic map to talk to map to send data and receive data from the map, and we need EAB response, and it is done by system. System is going to define. You need not worry about that. DFHAID you have to copy. Okay, it contains values of keyboard characters because we are going to write screen programming. In screen programming, we are going to receive data from the screen as well as we are going to receive what key they have pressed in the program. Okay, what key they have pressed. And since it's a screen programming, programs will be linked to each other. There will be plenty of programs linked to each other. So when programs are linked to each other, we are going to send data across programs. We send working storage data through communication area, and we receive communication area in linkage section. So when data is sent from one program to another program, we receive through linkage section. And communication area can be maximum 32K bytes. That's a maximum you can transfer across programs. But if you want to send lakhs of bytes, there are other ways. And there are plenty of different technology where we can send more than 30K of data also. Okay, 30K itself is huge. 30,000 bytes itself is huge. But still, if you want to send more than 30K, there are possibilities. Okay, we have to send in a loop, or we can use MQ to send. We can. Okay, but let's take a Facebook profile. You're editing and pressing button, and so the program should understand you are pressing submit button. There can be many buttons: validate button, submit button, check for availability of Gmail ID buttons. So whichever button you have pressed, that keystroke should come to the program, and the data you entered should come to the program, right? So data is in symbolic map in mainframe in CICS, and the keys will be in DFHAID. Okay, so based on the key, and then if you say Facebook profile, and then it passes data from one program to another program to process. Finally, that program will insert data into table and send a response back, something like this. So programs are linked to each other. We don't have all the logic in one program. We have small logic in many programs. We send data across programs, and we send data through communication area. We send working storage data from one program to another program. When you receive, we receive in linkage section. So these are the 4 things you have to make sure you set up. Once you set up, what you can do? What are the commands? Can you guess? Can you tell me? You already aware. What are the commands?
Receive command for
Receive command for what?
screen to program.
Receive what?
Data from screen to program.
Data from
screen to program.
Screen to program. And it is going to receive in which structure? There are 2 structures I told you, right, in SQL CA. Input structure, output structure. In which structure?
Output structure.
See, when you receive and you're going to process in the program, it's going to be what?
Input structure.
Input. Okay, that's the input to the program. Output from the program. Input structure. That's good. Apart from receiving the data from screen to program, what else it receive? The key they have pressed. Okay, key user have pressed. Here you are the users. Okay, that's good. Then how to send data from program to screen? Send map. Yesterday we saw send map, right? Send map. Same send map command. But yesterday we sent only the empty map. Hereafter we are going to send data with a filled in map. So send data from from program to screen. From which structure? From output structure. See, only the initial setup is little, we have to understand the main basic concepts. Once you understood this concepts, it's going to be easy for you. Okay, it's going to be easy for you. And while sending, we have to erase the screen, make sure it is clear, clean, and then send. And we learned one more command. What is the command?
Read.
Return. Read is a command for files, but I haven't taught files yet. Return command. Return command sends control to
main program to CICS region.
Control to CICS region. CICS region. So remember, our programs are running under CICS region. CICS is running as a job in ZOS, and our program is running under CICS region. Once the program is done, we have to send control back to CICS region. So this is what we are going to. So now let me talk about, let me ask about pseudo conversational programming. Can you tell me what is pseudo conversational programming? It's a series of tasks, right? Pseudo conversational program happens in a series of tasks. It looks like a real conversation is happening, but it's based on it is with a series of tasks. So in a pseudo conversational programming, okay, in a pseudo conversational programming, what is the first iteration? This we saw last week, not last week, Monday. Whoever has very good memory, without any short-term memory loss, they'll be able to answer. First iteration, Kiran.
Pseudo conversation. Send empty.
Send empty map. Just send
empty map.
Empty map. That's good. Then stop. Return. See, I'm converting it to a command. Okay. Second iteration. onwards. Suppose you are going to keep on doing enquiry or adding, updating, deleting in a program or listing some data in a program, it's going to be in a loop. So what is after this, what we are going to do? User input.
Receive.
Okay. Receive.
And process.
Process. Process means validate. If valid means
Terminate.
if valid, yes means process. Still it's process anyway. No. Process means update database. Okay. Process means update or enquiry, whatever. Process means it could be enquire, update, delete, or it could be writing into table or file. Process. If no, okay, I'll just write. This is internal. I am removing this. Like how what Niraj should validate, process, and then what we are going to do? After processing, what are you going to do? You are going to inform the user, right? About the status. You're going to send map. So receive map, input into input structure, send map from output structure. So send an empty map. So this is first time. Only first time we are going to send empty map. Okay. Only first time. And then user is going to press type in data and press key. Okay. If key is, say enter is a process key. If key is enter, do this. If key is say F3, F3, what are you supposed to? Stop. End the transaction. End the transaction. End the transaction means what? Return. Same thing we are going to convert into a program. Okay, same thing we are going to convert into a program, but you have to understand this concept better. Okay, whatever I told earlier about the copybooks, you have to remember. But you need not by heart anything. Okay, if you see the program and understand, that is more than enough. You can do a copy paste. Software engineering is full of copy paste. Thousands of programs are lying in your project, in internet. You need to know what to copy, what to paste. You need to understand the requirement and try to get data here and there and write your own code, own logic. Finally, bring the output. That is the skill required for any software engineer. Memory is not required, but some memory is required. That's an inbuilt memory. Okay, so we are going to have a symbolic map, AAB response, DFHBLK, system defined, DFHAID, DFH COM area. I'll tell you another advantage of COM area. So we are going to receive. So this is the sequence. So this is, we can say, I'll say final iteration. User has decided to come out of the transaction. When the transaction started, we are going to send an empty map and stop. Then user is going to type the data and then press key. We are going to check what is key the user has pressed. If user has pressed enter key, we are going to process the data. Process means receive, process, validate and send. Receive, validate, process and send. Whenever user type in data and press the enter key, we are going to do this in a loop. If user presses F3 key, we are going to come out of the program. Return. If user presses any other key, we are going to say it's an invalid key pressed. So any doubts on this? Same thing I'm going to convert into a program, but still I have to tell few more things because the real-time programming it's not little easy, but if you understand clearly the concepts, it's going to be much easier. And if you write the code, it is going to work. Need not by heart the code. You see the code, understand the code, and just change, move here and there, add some code. That is more than enough. But you have to know what to change, what to add, and what to remove. So this is the real-time programming concepts of real-time programming concepts of many technology. All technology. Okay, everything evolved from mainframe. Everyone are going to use same, but but there are something little bit different. But this is the fundamental base. You would have experienced this in real time every day, right? We are browsing, we are using phone. How many times, or how many hours every day? So here, how many programs we are going to write? We are going to write only one program. Today we are going to write only one pseudo conversation program. Same program is going to execute. First time when the program executes, it has to know that it's a first iteration. Second time, and when the program executes the second time, it has to know it's a second iteration. Same program you are going to execute in a loop. Okay, same program we are going to execute in a loop in a conversational mode. Forget about pseudo conversation, but in a conversational mode. Only one program. And we have to understand whether it's a first iteration or next iteration. Next iteration based on the key. Okay, based on, I'm not going to say it's a final iteration. I'm just removing this. Second iteration onwards. Okay, second iteration onwards. If key is enter, do it. If key is F3, do this. If key is anything else, stop. Say it's an invalid key pressed. That's easy to do it. I'm going to convert this as code, and code is going to be much easier. Okay, I'm going to convert as a very simple code, so don't worry about that. I'm not writing a very complex code. So there are basically two variations. One is first iteration, second iteration onwards in the same program. Okay, so we have to identify. So how will you identify? Based on a keyword called EIB communication area length. Okay, EIB execute interface block communication area length. Communication area length. So communication is happening across programs as well as within the same program also in online. You have to understand that. So communication can happen across programs. That's what you did in batch. We sent data from one program to another program. We received data through linkage section in another program. But right now we are going to send data within the same program. But right now we need not send any data because we are not going to write advanced kicks. We are going to write very basic kicks. And many people don't know basic kicks also. Okay, even in people, so we are seniors, some seniors, we will find. But if you know basic kicks, that is going to be a big, confidence building measure. Coming back to here, so we have a field called EAB Callan. So EAB Callan, again, it's a part of DFHBMSCA. So I told you a copybook called DFHBMSCA. So DFHBMSCA is defined by system. So it is going to have EIB response and EIB Callan, and we have another EIB-AID. EIB-AID means execute interface block attention identifier. When user presses any key in the keyboard, value of that will be in EIB-AID. Contains value contains value of keyboard or key pressed in keyboard. And EAB calendar is going to have contains com area. Okay, contains length of com area. Sorry, contains length of com area. It's not com area. Contains length of com area. Across iterations or across programs. But here we are not going to write more than one program. We are going to write only one program, and we are going to have multiple iterations in the same program. Okay, so you have to understand this. So in DFHEABLK copybook, there are three important fields. One is EAB response, which is going to be checked after every kicks command, and EAB8. EAB8 is going to contain the value of keystroke after a user presses any key in the keyboard to process, and EAB callen is going to contain the length of com area across iteration or within same program or across programs. So this what happens when the iteration in the first iteration, when the program freshly starts, EAB callen will be 0. Will be 0. And second iteration onwards, EAB callen will be greater than 0. So this is how we find whether it's the first iteration or second iteration onwards. You got it? So we are going to use a field in DFHEABLK to identify whether it's first iteration or second iteration. If it's first iteration, we are going to send an empty map and return. If it's a second iteration, so you can just say if condition, that's all. If EAB callen equal to 0, send and return, that's all, done. Else, receive, process and send, end if. Very simple. Okay. So programmatically we can convert this very easily. So when EAB callen equal to 0, or we evaluate EAB response or something, and then if EAB callen equal to 0, the first iteration, else it is a second iteration onwards. In second iteration, what we do? We check whether the key is enter, then receive, process and send. If key is PF3, we end the transaction. If key is anything else, we'll tell the system that's an invalid key pressed. Okay, got it? If you want to take a screenshot of this, and there is one more minute thing I have to tell you, and then we can proceed with writing a program. Okay, probably I'll move this. So return exec kicks return end exec. So what does this command does? This command we already used a couple of days back.
Returns control from main program to CICS region.
That's good. Returns control from main program to kicks region, or it's going to stop the program, stop the execution of program, like go back. Okay, it's like go back. If return is used in subprogram, here it's called a linked program. In linked program, return command sends control back to say main program. So you would have seen many programs with main menus, sub menus, right? In sub menu, if you give a return, it comes back to main program. So that's how people design the program. So there is another command of return, CICS, return trans ID, transaction code. Transaction code is user defined. COM area, say working storage, record or variable, and then index. So there is one more return command which we are going to use today. Okay, this return command is going to stop execution of program. This return command, what it's going to do, stop execution and return to same program when user presses any 8 key. So you have to understand this. If you understand this, then it is done. I'll just explain again. Here it's going to stop the execution of program. It is done. We wrote this command a couple of days back. So if you write along with return, we can pass couple of parameters. One is return trans ID or COM area. So we write with trans ID, we are going to give a transaction code here. What this command does, it stops execution and return the control to the program, same program, not same program. In fact, we can say to program given in tran code or trans ID field. To program given in trans ID field, return to say program given in trans ID when user presses any 8 key. Okay, what I will do, I'll just open the PPT slides. So now you see minutely what is happening. In pseudo conversational programming. It's going to be very easy, but you have to understand the concepts. So first time when user presses the transaction code and press enter key, okay, it's a first iteration. So EAB communication area length is 0. First time say it's a transaction code. Here we have say GA01, some transaction code. This is attached to what's the program name? G01 PGM1. So something like this. Okay. Gamma, right? GA. This is a transaction code. This is a program. When you write this transaction code in this program, we are going to write logic. When the user presses 8 key, when the user invokes a transaction first time, so communication area length is 0. So EAB is equal to 0. What we are going to do? Send map from output, then return trans ID. We are going to give same trans ID, and COM area, I'll tell about COM area again. Some working storage variable. That's all. These are two commands you are going to write if EAB colon equal to 0. So first iteration is identified by EAB colon equal to 0. If it is first iteration, we are going to send a map which is going to be empty. Then we are going to return. So we are returning, we are going to say return with trans ID GA01. So what we are saying, what does return does? It is going to stop the execution of program. See, when the user, it is going to stop the execution of program and release all the resources. And when user types in data, so user types in data and press enter key. When user types in data and press enter key, what happens? So whatever transaction code we have given here, that is going to be invoked. It could be any transaction code, but here in our case we are going to give the same transaction code because we are writing the entire logic in same program. I mean entire pseudo conversation logic we are writing in same program. So same program should be executed in a loop. Okay, and in first iteration it should recognize it's a first iteration and send empty map and stop. And second iteration onwards it should recognize second iteration onwards and then process, receive, process and send and stop. So when we are stopping, what we are going to say, return to the same transaction. That's what it means. Return means stop to the return to the same transaction using when the user presses 8 key. Okay, what user is going to do after entering all the data, they are going to press a 8 key. This is called 8 key, attention identifier key. It could be everything is 8 key in keyboard. Not everything. There are all function keys, control key. I mean all function keys, control, enter key. These are 8 keys. And there are some keys called alt function keys. There are around 27 keys which are called 8 keys. But we never use all those. We use only the function keys and enter key. You can understand there are 12 function keys in the keyboard plus one enter key. So these are some called 8 keys. 8 stands for attention identifier. So what user is going to do? User is going to type in data and press an 8 key. So when they press 8 key, what happens? Whatever trans ID we have mentioned here, that transaction is going to be invoked again. Now when it is invoked again, EAB colon will be greater than 0. When if it is greater than 0, what we are going to do? We are going to receive, process and send again. Receive, process, send and again return with trans ID GA01. So this is going to be in a loop. If user just press F3, F3 means end of transaction. We are just going to write return. Return means it is going to stop the execution of program. So there are two types of return. One is return, just return. Return is going to stop the execution of program, send control back to CICS. Here we are going to write only one program, main program. We are not talking about subprogram at all. There are different types of subprograms. We will be dealing tomorrow. I will be explaining tomorrow. That's very easy. But this is the main concepts of any pseudo conversational technique in any technology. You have to understand this. If you understand this, then you are done. Anyway, I'll be explaining again tomorrow and day after tomorrow also, and you'll be writing programs. Once you write 2-3 programs, you will understand much better. Now I'm sure you understood. Many people have understood 50%. Some people up to 70%. That is 50% also is more than enough. Okay, once you have started writing 2-3 programs, you understand how it works, because you are going to feel how an online program is going to work. Okay, so there are two types of return commands. One is just return, return within exec CICS and end exec. It is going to send control back to CICS region and stop the execution of program. And there is one more return command, return with trans ID transaction code. So in a pseudo conversation technique, if you write in a program, we are going to do multiple iterations. So this the trans ID, the transaction code, it denotes the same transaction code. So when you do return with trans ID transaction code, after user types in data and presses an 8 key, it is going to invoke the same program. And when it invokes second time, it's a second iteration. In second iteration, we are going to have a different logic. We are going to have an evaluate or if statement and evaluate EAB colon. Then we'll identify it is a second iteration, and then we'll make sure we receive, process, and send. This will be continued in a loop. If user decides to come out of the transaction, they are going to press F3 or any other key. For F3, we can write a code in such a way we write only return command. So if you write just return command, it is going to return the control kicks. It's going to stop the execution of program. So there are two return commands. You have to understand the difference between these two. So just a simple return command or return with transit. So we are going to write a pseudo conversation program, and we are going to have a conversation program through screens. So we are going to send data from screen, receive data into the screen from program, and we are going to press after typing data. We are going to press an 8 key in keyboard to make sure program process the data we have entered. So this is what you are doing for a long time, every day in browsing, when you are browsing the data. So when what happens when the user first time when the user invokes a transaction, we are going to see an empty map. Okay, empty map. User is going to type the data and press enter to process, enter or any key. Then it's a second iteration. You have to know it's a second iteration. In second iteration onwards, the sequences receive, process, and send. So in second iteration, how do you know it's second iteration? Based on communication area length. If communication area length is not 0, it means it's a or greater than 0, it means it's a second iteration onwards. Then you check the key, value of key. If value of key is say F3, return command. If the value of key is any other key or process enter key, it's going to be receive, process, and send. Receive, process, send, and return. Okay, there are 4 commands. Return with transit. Again here return with transit. That's all. Here just return command. If any other key is pressed, you have to say it's an invalid key. If any other key is pressed, you have to say invalid key and then again return with transit. If any other key is pressed, again receive. If any other key is pressed, you can directly send a map with a message and then end the transaction. Again return with transit. Again, I added a few more things. Probably if you want, again for any other key is pressed, it's going to be. I'll just write that also. Any other key, invalid key, it's going to be send map and return with trans ID. Trans ID and is going to point to same transaction code. So this is the main concept of pseudo conversational programming, and I've written in comments. So yesterday when I told you 2 days before when we saw the PPT, you understood. That's what we are doing in real time also in all new technology. In old technology, same way. Everything new technology is just evolution of old technology. And the sequence is first iteration, second iteration onwards. In first iteration, empty map, return. Return means because the program cannot stay in the same storage. That's why it stops. Return means stops execution. But restart the same program when the user presses 8 key after entering the input. That's what it means. Return with trans ID means after user types in all data, user can take their own time. No issues. once they press 8 key, restart the same transaction. When you restart same transaction, now EAB column will be greater than 0. And if it's greater than 0, we are going to have receive, process and send. And we can just, based on the key press, we can take appropriate action. If key press is F3, you can end the transaction. If key press is enter, receive, process, send, and then stop, return with trans ID. If any other key, send with an invalid message, return with trans ID. So, and then I told you there are two types of return command. One just return, next return with trans ID and com area. Return with trans ID com area means it's going to return with the same. When the user types in data and press enter key, it is going to return the control to the same transaction code and invokes the program again. Very good. Which are the, how many input fields are there? How many output fields are there?
3 input fields, sir.
3 input fields. In fact, total is also protected. I haven't written. So now, if you see unprotected, it means it's an input field. Okay, if you see protected means output field. Sometimes a field can be input and output together. Okay. Okay. So what I will do? See here, this you have to give pick in, pick out like this. Pick in 9 of 4, pick out 9 of 4 or Z of 4. So here again pick in 9 of 5, pick out Z of 5. Here I use a very important keyword called FSET. Even Mrityunjay asked me yesterday. I'll tell about FSET. It's a big topic and it's a very important topic also. It will be a little complex. Tomorrow I'll explain. It will be a little confusing. So what I will do, I'll just copy this code. So when you give star, don't go up to 72. Some people will have an intention to go up to 72. If you write star in 72, it get confused. Okay, you can give comment in, if you give star in one line, it means it's a commented line, but don't give star up to 72. So I'll just copy paste. Since you're aware and you're not going to create any map in project for sure, and even if you can create, you will not have access. It is done by administrator, and for writing one map, it is done by managers. Only managers and senior managers are going to do. Okay, even if you design a small file in the project also, like employee ID, what are the fields you are going to store, what is the length, what is the type, it is not given to a normal developer. End of the developer is going to write programs, but the small design of file or table also is being done by managers. You understand? Who is managers here? We have two managers, Hari and Niroj. So they are the ones who can do, who are eligible to design. Even I remember 10 years back, there was a program. I designed a program. In fact, it's a very good design. I copied the design. We are going to change the program every day, every week. We had robots. Okay, we installed robots. You would have heard about RPA, robot process automation. There are robots done in mainframe also. So we installed robots. We have to install robots. For installing robots, every week we have to change the program. So, but I gave a different architecture, very beautiful architecture, where we never touch the program. We just change a small file, and it is good. We can bring down the robot development effort from around 24-32 hours to just 1 or 2 hours. Every week, I am reducing the effort from 24-30 hours to just 1 hour. Okay, I'm reducing the. But what happened? My senior manager, he was in US, very brilliant guy. He called me. He said, "No one should design. Only I should design." That's what he told me. He's a very senior manager. He was around a director role in Verizon Telecom. He said, "Only I should design. No one should design." Then find it's a good design. And after a week, he called me and said, "What happened to the design?" I said, "I told him, you only told you are the only person who can design. So I dropped the design. I didn't install in production." He said, "It was a very good design. But since you said, I dropped." So that's what they do in projects. There will be a lot of politics. Politics itself is big. Okay. We will be writing programs. And Harindra and Niroj says, "I wrote the program and showed it to the senior managers." You have to be very careful with them. Okay. Even we can upload this into the mainframe also. I'll tell you how to upload. But in Mocha, I don't think you can do it. We have to install IBM PCOM or Vista. So since you're aware about this, I'm going to compile directly. Max is 0. So when we compile, what happened? So in compile,
Symbolic map has been put.
Symbolic map is created. First, let me show the screen, then I will show the symbolic map. Symbolic map is in gamma01.copylib. It's a working storage structure which you are going to copy in the program. Okay, this is the copylib. Let me show the screen. After this, I will write the program and show you. Still one concept I didn't tell. I will tell the concept. Okay. Okay, CECI, send map add. I changed to map add, Mapset, G01 MPS2. Oh my god, ABM0 means incorrect map name. Okay, spelling mistake. So this is the map. Addition of two numbers, number 1, number 2, total. These are labels. 9 of 4, 9 of 4, 9 of 5. Okay, I can show it in this notepad also. So addition of two numbers, say in 1, 2, 3, 4th line, probably in 10th line, number 1, there are 3 variables. One is label, field and skipper. Label, field, skipper, label, field, stopper. And message is hidden here. This is the final line. Okay. See, number 1, unprotected IC, initial cursor. Since I given IC here, cursor is here. Number F set 9 of 4, 9 of 4, and A skip. So I've given star between these so that it's easy to understand. Number 2, unprotected number F set. So and total it need not be unprotected. It can be protected in fact. Okay, it's so these are some in 22 the bright yellow. So this is the screen. You know already. So but we cannot do anything now. Okay, we have to just and what to process. F1 to process or press enter to process. F2 to clear screen. Clear screen means clear the screen. Send an empty map. F3 means end the transaction. So F3 to end the transaction. F2 to clear screen. Clear screen means clear the data. And F1 to display total. Okay, this just a map. I haven't written any program now. I have the program ready, but let me tell about the map. So in map, we have three variables: NO1, NO2, and total, and message. Okay, these four variables will be in both input and output structure. Okay, these four variables will be in both input and output structure. In input structure, it will have a suffix as I. Suffix as I. In output structure, it will have suffix as O. That's all. And both the input and output structure is redefined. So what is redefined? Can you guys remember what is redefined? Redefined we learned a long time back.
Same number of bytes can be given, sir.
Yes, we are going to use
Same memory space, sir. What we have defined for other level
that's
number.
good. I'll show you in the structure. See, the input structure is your map name suffix I. Map name is map add. Okay, map add, there's the one I gave. So map add I is the input structure. Map add O is the output structure. In map add I, we'll be having number 1 I, number 2 I, total I, message I. In map add O, we are going to have number 1 O, number 2 O, total O, and message O. And both are redefined. If it's redefined, it means it's going to use same storage. So whatever is present in NO1I will be in NO1O also. Okay, whatever is present in NO2I will be in NO2O also. So you need not explicitly move. So I will show you the screen. So map add O is the output structure. Here there are many unnecessary fields. I'll just delete those fields. And those fields are system fields, okay? Just hold on. Again, call from NIT. So they are asking me to copy the copy all the videos to share drive. So did you guys copy the assessment and project till what we did? I didn't follow up with you.
No, sir.
Okay. Okay. Who has a very good internet connection here?
Sir, it is taking so much time to download.
What? Taking so much time to
Download the videos.
download the video. That's why I'm asking who has good internet connection. Because looks like we have to upload everything. And so let us proceed. So as far as symbolic map is concerned, we have two structures. One is input structure and output structure. We receive map into input structure and we send map from output structure. And these two structures will have the name of map name suffixed with I or O. I means input structure, O means output structure. So all the fields will be in both I and as well as O. Okay, don't think input fields, unprotected fields will be in I, protected fields will be in O. Okay, all the fields whichever has field name will be in both input structure as well as in output structure. And since both the structures are redefined, whatever data is in I variable will be in O variable also. And variables are easily defined. Okay, that's a dummy. Okay, these are the variables. Okay, these are two structures you have to pay attention in symbolic map. So map add I is the input structure which will be used in receive. Map add O will be output structure. Since they are redefined, whatever is present in NO1I will be in NO1O. We need not move NO1I to NO1O before send map. Data will be already there. Similarly, NO2I, all the fields defined in the map. See NO1, NO2, total and message. We have some dummy field that's not required. Okay, I'll remove this dummy field. So NO1 is picture class 9 of 4. NO2 is 9 of 4. Total is pickin. Pickin means in input structure will be 9 of 5. Output structure Z of 5. Message will be length 79. So same way it is going to create either alphanumeric or numeric. So 9 of 4, 9 of 4, 9 of 5, X of 79, 9 of 4, 9 of 4. Since we gave pick out as Z of 5. So this is what is going to be present in map. And apart from this, there is one more variable, L variable. Okay, there will be L variable. So there will be L stands for length. Okay, in the input structure. So in the L, so whatever data you have typed, that length will be here in L. Okay, and moreover, that is for receiving. In sending, if you can move -1 to this length field. Okay, if my L will be an S9 of 4 comp. Okay, S9 of 4 comp field. 9 of 4. So this L, I have to put my phone on mute. I think I'm getting calls unnecessarily. So this L field is part of input structure. So when you are sending the map to the output, in the output, if you move -1 to the length field, you can place the cursor in that field. Okay, you could have seen in the real time in any screens you are using right now. Suppose you are creating a profile in Facebook or anywhere. When you type in data, first time the cursor will be in first field, first unprotected field. And when you type in data, say 10 fields, and you're pressing submit button, suppose some 8 fields or 9 fields are having correct data. So now the cursor will be in the incorrect field. Okay, cursor will not be in the first field. Cursor will be in the incorrect field. Make sure. So how it is possible in CICS? In maps, we move -1. Suppose number 1, number 2. Number 1 is, we are going to add 2 numbers. If number 1 is a proper number, number 2 is not a improper number, we can place the cursor in number 2 field. How to place the cursor? Move -1 to number 2L and then send map. It is going to place the cursor. That's what right now you need to know about the symbolic maps. We have two structures, one for input, one for output. Both are redefined, meaning same storage. Now it is, see, now it is going to have one more data here, okay, but 2 more bytes. I'll delete this because I've deleted many things. I haven't, many things I have deleted. I'll explain that later. Right now, these are the variables you should pay attention to. Okay, and you know this is created based on the field name and map name you are given in BMS. So this map we are going to copy G01 MPS2 we are going to copy in the program. Now let me write the program directly. It's time to write the program. This program, this map, what is going to do? It's going to add 2 numbers. We are going to input 2 numbers and press enter. It has to add and display total here. If you press F3, it has to come out of the program. Okay, if you press F3, it has to stop the execution of program. If you press enter, it has to add and then display. And user can add any number of numbers until user presses F3, it will be in the same program. So source lib. Okay, I'm going to rename this program to G01. Okay, hold something. Yes, G01. We have only 3 programs limit, right? So I'll define our new program for you today. So don't use the same program. You can use G01 PGM4. I'll define one program today. Let me go to this. My MPS2. PGM2. Yeah. Very simple program. Full conversation. Pseudo conversation. Grammatically is very easy. So I'll tell you how it works. Whatever we have seen before the break, same logic. Okay. So as I told you earlier, so we are going to copy the symbolic map. Okay, we are going to copy symbolic map. We are going to copy one more copybook called DFHAID. What DFHAID is going to contain? It is going to contain the list of all the keyboard strokes along with value. And we have we need to copy DFHEIBLK, but DFHEIBLK, I mean, it's automatically gets copied while compiling. I'll tell about DFH com area shortly. Okay, I didn't copy properly. These two lines I missed. Okay, map name is map add, right?
Yes, sir.
I
You
have
have
to
given
do
map add.
some change. I have to do some changes. So map transaction is G013.
Sir, in procedure division, you have given map add one was.
Procedure division.
Yes, sir.
F map add 1.
Map add no, sir. Map name.
Add. See, the program is very small. How many lines? Just 68 lines. And it does the full pseudo conversation program. So we need to copy these two copybooks. DFHBMSCA gets copied automatically, and we need to copy com area. Com area is given. There is no. We are not going to pass any data across iterations. Okay, so that is a little very complex logic, complex program, and here we are not going to write any complex program. So there is nothing to be transferred across iterations. So we are not passing, but com area is required for sure. Okay, when you send the data, we receive through linkage section. That's why com area is given in linkage section. Okay, we can send data from this program to another program. Here we are sending working storage data. There we are receiving in linkage section. But idea of using com area here is to send data within the same program. Even within the same program, you are sending working storage data and then receiving through linkage section. I will come to com area again. So I'll tell the high level logic. So by default, whatever data we are seeing in the map is low values. Okay, low value is the lowest value in mainframe. Okay, low value denotes hexadecimal 00. Okay, low value is the lowest value. So generally we move low values when you're sending an empty map. Sometimes we can move spaces also. Even spaces also is going to clear the map. So either move low values or spaces. So when EAB colon equal to 0, what are we supposed to do? Tell me the logic. If EAB colon equal to 0, first what?
Send
EAB
map.
colon equal to 0. Send empty map and return transit. Okay, return with transit. EAB colon equal to 0. We are moving low values means to map add 1000 send map. Let's see what is 1000 send map. Send map name, mapset name from output structure erase. So what it does, it erases the screen and send the map. And what is there in map add O? The output structure, nothing, right? Because we are moving low values. We can move low values or spaces. So 1000 send map, or I'll move spaces also. So when EAB colon is 0, this is procedure division, right? So I'll put dot here. When EAB colon equal to 0, we are moving spaces, but low values is the standard we are using in projects. Okay, we use low values. It's similar to spaces. I will tell you what is low value later. And then 1000 send map. Then control comes where? Outside this if, right? Outside this if. After end if. Then what we have written? Return trans ID transaction code, and COM area, some WS COM area. So what is this G013? Which transaction code? Transaction code of which program?
Third program.
Same program. Same program, right? Okay, because as far as pseudo conversation technique is concerned, after every iteration, program stops executing, load is deleted from main memory. And since we are going to start the same program, once the user presses the 8 key, that we are going to tell the transaction code. Use the same transaction code, kickstart again. So when it kickstarts again, what will be the EAB calendar value?
Greater than
Greater than 0. So it is not going to come here. It is going to come in else part. And then what we are going to do? We are going to evaluate the key. So I told you the value of key will be stored in EAB8. Okay, and we have list of values stored in this copybook. How do you check whether this key is PF3 is pressed or enter is pressed? We have a function, and it's very easy to use. Okay, you can, these are some value. So DFHPF3 is it's a field in DFHAID which has the value. So we are checking whether EAB8 equal to DFHPF3. Okay, what I will do, I'll just compile and show you. That's a Kix compile. This is the one Fusion. Max is 0, that's good. Because DFHAID is a copybook, system copybook, I don't know where it is stored now. I had to do a little research. But here it will get expanded. DFHAID. So it is expanded. You can see it is expanded. C means it is expanded. Here for every keyboard character there will be value. See, DFH enter means some quotes. And these are some 8 keys. DFH clear screen. Clear, if you press clear screen in keyboard, it will have this value. Similar DFH PF3. PF3 means some 3 value will be given to the keyboard stroke. So what we are doing, we are checking. EAB is not there. Okay. We are checking in the program whether EAB8 value is equal to DFHPF3. Okay. So EAB8 is going to have the value, whatever key user is pressing. We are just going to compare. If the value is same, if it is PF3, what are we supposed to do? We are going to stop the transaction. We are sending a text. This is another command. Like yesterday we used a send command 2 days back. Send from input, right? Send from input working storage. This is another send text command. Using send text command, we can write multiple lines also. Even Tarun asked how to write multiple lines. Okay, like maturity amount in one line, principal amount in one line. You can use send text. So the advanced, syntax of send text, but we can write multiple lines. But we are not going to deal with that right now. Send text from some message. It's a working storage structure. We are saying end of transaction. Just end of transaction. Erase and free KB. So whenever you use a send command, do a free KB. Okay, whenever you use a send command, do a free KB. Otherwise, your keyboard is going to get logged. Even here also, free KB is required. So send mapset from mapadd erase free KB. So when user presses F3, he has decided to come out of the transaction. So we are going, and when user presses F3, the value of EAB8 will be the value of F3, and we are comparing with DFHPF3, which is a field in DFHAID. And if it is equal, we are sending a message to the user, transaction ended, and then return. Return means it stops the execution of transaction. If user presses any other key apart from F3 or enter or F1, what we are going to do, we are moving invalid key pressed to message O. What is message O? It's a field in output structure, and then calling the 1000 send map. So it goes to 1000 send map means again send map set from map add O. After send map, what it is we are going to do, again we are doing return trans ID com area. So I'm just going to compare this with this. The first iteration, if EAB colon equal to 0, send map return with trans ID. Even EAB colon greater than 0, check evaluate the EAB8. If EAB8 is PF3, end the transaction.
So if we have more than PF 10 up to 10.
See, we have PF24, 1 to 24. Okay, in olden days, in olden keyboard, we have 24. Even here we are having 12 keys, right? If you use Shift and F1, it's PF13. If you use Shift and F2, PF14. So we have up to PF24, and we have Alt keys also. Alt and F1 is called PA1. Alt and F2, PA2. Okay, we have 12 PA keys, 24 PF keys, and control, erase, all these are 8 keys. For our other keys, it is going to, we are going to just say invalid key pressed. That's all. Any other key, if F3 is pressed, we are going to be sending a text and then stop. Stop means by using return command. It ends the execution of transaction. If any other key apart from F3, I'll remove this also. Or we can write F1, DFHBMSCA. I'll remove this. If PF3 is pressed, we are sending a message, stops. If enter is pressed, we are doing some processing. Processing means receive, process, send, and return. And if any other key is pressed, we are going to just send an invalid message and then return. For every command which is executed, it comes down and execute this. Return trans ID G0130. G030. So what you asked? Okay, let's move on. If EAB8 equal to enter, the control comes to 2000 process map. 2000 process map, what we do? We receive, process, and send. What is this program is really doing? We are going to sum, right? Sum these and store here. So when you press enter, NO1I will be having 43. NO2 make it as 1. I'll make it as 100. 200. When you press enter key, NO1I will be having 100. NO1I and O will be having 100. Again NO2I and NO2O also will be having 200 because those are redefined. When you press enter, we have to receive the map. After receiving map, we are going to calculate NO1, add NO1I and NO2I and store in total O. That's all. That's what we are doing. NO1I, we can straight away add also. This is not really required because it's already a number. We need not move in a working storage. Straight away you can add NO1I and NO2I. It's a 9 of 4, right? So no issues. And here we can write total O. I'm just making program very simple. Just only single command. And perform 1000 send map. If you don't want 1000 send map, I will copy paste all that also. 1000 send map, what I will do? I'll cut and copy. So in process, what we are doing, we are receiving map name, mapset name into the structure. So map ID will be filled. So NO1I will be having value, will be having 100. NO2I will be having 200. Both these add and put in total O. Then send map. After send map, what we are supposed to do? The return command. Return with trans ID. Anyway, it's a evaluate. After evaluate, after processing, it has to come out of this endif and execute this here. So I'm just reducing. Okay. This is not required. So instead of send text also, we can use send input, like what we did yesterday. Okay, yesterday we used send text only, right? Send text from length, okay.
Sir, text was not there, sir.
So length was not there. Text was not there. Yesterday we had length also.
Yes, sir.
Okay, send from input length. If you want, I will use the same. Send from WS output length. Here is. So WS output, WS length. I will make it as WS output. And WS end we will define. I'll give value here itself, okay? 37. And it's not going to change, right? So if it's not, something is not going to change, can give it in working storage section itself. That's our program has become very small. So program, so this is a message we are going to say when the user presses F3, and com area is just for formality, and linkage section. So how do you use com area? Usually when you send data from one program to another program, in the receiving program we define com area in linkage section, and in the main program we send data, the working storage data, in com area. That is across programs. So but within the same program, what we do, in the return command, we write com area some working storage area, but this we are not using this. I'm just explaining because in future if you want you can use the com area, and this com area can be up to 32 KB. Okay, you can send, if you want to send some data across iterations within program, com area is the only way. So here I'm just sending some junk data, and then return trans ID, same transaction code, com area, WS com area. WS com area is the working storage. And if you want to receive in the same program, it should be using in linkage section. And this is a system keyword, use DFH com area always. And this 1 byte we are receiving here. This 1 byte say value, nothing. It's value spaces. Here I am just explaining how we receive com area. So and in the second iteration you can receive like this, move DFH com area to WS com area, so that you can use in the program. Even you can use DFH com area field directly also. Okay, you can use DFH com area field directly also. So let me compile one more time. I'm going to compile one more time, I'm going to explain one more time, and then I'm going to execute the program and show you. Okay, nice. See, it's everything is reverse. Message log in TRN, there's a 8. Go to TRN. Option free KB is not valid and is ignored. Oh, in line number 27. The free KB cannot be used in send from input. Line number 27. Here we cannot use free KB. I am going to remove this. But free KB is not mandatory to be given because free KB is already defined in BMS. Okay, now let me explain the program. So first time EAB colon is going to be 0. We are going to move low values or spaces to output structure, send map and return. So its send map is in a paragraph. Okay, send map is in a paragraph. If you want, I will just remove this paragraph also. I'll just remove this paragraph. So to make program much simpler, I'm just doing to make program much simpler for you to read and understand. Later you can put in a paragraph and call the paragraph. So move low values, send an empty map, and it comes out of the endif. Return trans ID com area WS com area. WS com area is a field in working storage section. Then second iteration, user is inputting data and pressing enter key. Here it's a addition of two numbers. When they press enter key, any key, the control comes to else part of EAB colon. Else part of EAB colon. And now we are going to check the value stored in EAB8 against the values in DFHAID. If it is PF3 is pressed, we are sending a message and then stopping the program. Message is end of transaction. If other key is pressed, we are moving a message in message field, message O, which will be in the 23rd line, and sending an empty map. Okay, again this map is not there. But I mean, repeating the code is, instead of repeating the code, better to write paragraphs. I think I did incorrectly, right? So it's very glaring. Here perform what? 2000 process map. Okay. So when second iteration onwards is going to check if PF3 means it sends a message and stops. If it's any other key apart from PF3 or enter key, the control comes to when other. We are saying invalid key pressed and sending the map. So in map add O, everything will be the same data except message. Message is a new message. Okay, and now, and when you're pressing enter, after this, it's going to execute return command. When you press enter, we are executing 2000 process map. In 2000 process map, what we have done, we have received, we have computed, and then sending the map again. Okay, and it can move calculator, something fully. So otherwise, it's going to have a old message to message O. And then send the map with data. After sending the map, the control comes out of this process map outside this endif outside this end evaluate, then outside this end, then executes the return transaction. So let me compile this one more time and then execute and show you. Okay, let me log on. It's time to log on to CICS. F3. Okay, it got disconnected. Better to write in a paragraph and call that command. CMT set, first time it's not required, anyway I'll write it. Okay, anyway it's already executed earlier, right? So I need to do it for sure. G03, so G01, PGM3. That's all. Normal. Now clear the screen. How to execute G01, PGM3, G01, 3. Press enter. So this is how we are going to execute any online program. Now we are going to write a conversation program, not non-conversation program. When I pressed enter for the first time, EAB calendar equal to 0, it sent an empty map, return with trans ID. That's what happened. First time when I did this, what happened? EAB calendar equal to 0, send empty map, return with trans ID. So program really released. I am a user, I can enter any number after taking a coffee also. Slowly I am entering 0 to 100. Okay, 200. How to process? Which is the key to process?
Enter.
Enter.
When I press enter key, now EAB calendar is greater than 0. Second time. When I press enter key, the control go to else part in the evaluate. And since I pressed the enter key, it is going to process. It is going to process map. 2000 process map. And then, so 2000 process map, it's going to be receive, calculate, and it is going to show total O, and it is going to show message O also. Send map and then stop. I'm pressing enter. Why it is showing blank here?
We taken the
Four
size as
digit.
nano form.
4 digit.
What?
5 digit.
Taken 4 bytes.
Z of 5, that's good. I gave Z of 5. I didn't give 9 of 5. If I give 9 of 5, it would have shown 00300. Since I gave Z of 5, the leading zeros have been masked. So I wrote a message calculated successfully, right? Okay. Now I am pressing an invalid key. Say F5. F5 we didn't handle. What it did in the program?
Invalid key press to message output.
Okay, in program it went to when other. Invalid key press to message O, send the map and return trans ID. Okay, now I'm adding 2 more numbers. Say 0, 900, 0, 300. Press enter. 1000. So this map is going to be, this program is going to be used continuously, any number of times, till user presses what? I haven't given any functionality for F2. Okay. F1 also no, I didn't give anything. If I press F1, F2, it is going to show invalid key because I didn't handle it in program.
Only F3 you have given.
Yes, F3 and enter. If I press F3 now, what is going to happen?
Deletes all the data.
That's right. But F3, what is F3?
Close the screen.
Close the screen.
It's going to send a message. It's going to erase first. It is going to erase the screen. So the screen is going to be blank. Then it is going to send a message. What message? End of transaction. And then return. If you want to stop a program, just return, like go back. Press F3, stops. That's all. Is it very tough? I'll execute again. G013. First iteration 0500. 0500. Okay, I've given a skipper field or stopper field. I think I gave a stopper field here. That's why the cursor comes here. If I give a skipper field, the data would come in, cursor would have come here. I gave a stopper field to enter, calculated successfully. You can use it any number of times. Beyond this, we cannot add. This is a small calculator program. So, do you want me to explain again one more time, or and we understanding this is important. Okay, first, see, these copybooks are must. First, we are going to copy the symbolic map. We are going to copy the values of the keys, which is stored in DFHAID copybook. Okay, and we have DFHEABLK. So DFHEABLK is going to contain EAB Callan, EAB AID. Okay, DFHEABLK I will show you here. It will be in COBOL compilation. You saw DFHAID, right? DFHAID I just showed you. We copied manually, user defined. And DFHEABLK is see here. It copied in linkage section automatically. In DFHEABLK, it's a copybook, system copybook. It's like SQL CA. So it has EAB Callan. EAB Callan is S904. And we used EAB AID, right? These two fields we used. EAB Callan and EAB AID. And we have something called EAB response. EAB response. EAB response. This is a response code. It's like SQL code. So DFHEABLK, it gets copied in linkage section automatically. So these are the copybooks required. That's what we discussed in the morning. Symbolic map, DFHEABLK, system defined, or system is defined. We are using Callan, EAB8. And EAB response I will use tomorrow. Now, right now it's not required. Writing a very big complex logic CICS program is very tough. Not only in here, any technology. Not very tough. We need to handle a lot of things. Okay, we need to handle every minute thing because it is going to be shown to user, customer. Customer can respond in any manner. Okay, they can use any keys in the keyboard. They can keep on pressing submit button. And we need to we need to make sure when there are 25 fields, when 20 fields are already processed, we need to make sure it is protected. We need not allow them to write again. That's one thing. Second, we need to make sure it is protected, and we need not validate again. Okay, once it is validated, it is done. There is no point of validating the same field again and again. So the logic will be little different in how we handle that. So all these are advanced programming. Okay, advanced programming is not required now. It's not part of training also. Learning this itself is a big thing, if you ask me.
Sir, in program, where did you declare the enter key, sir?
Enter key, see EAB AID, when user presses enter key, EAB AID will be filled with value. And in the program, here, in the program I'm checking whether EAB AID equal to DFH enter. We need not remember the value. For every key, there's a value attached to it. For that value will be given in a copybook called DFHAID. And in DFHAID, if you go to DFHAID, it has a list of all the keys with their corresponding value. So here, if you go to DFH enter, this is a value stored in, this is a value for DFH enter, enter key. So when user presses enter, the value of keyboard will be stored in EAB8, and we are checking whether EAB8 equal to DFH enter. Instead of checking if EAB8 equal to like this, it's like a double quote. Okay, instead of checking like this, we are checking DFH enter, because all these are inbuilt copybooks. it's very easy to use inbuilt copybooks rather than hard coding the value, and we cannot remember all these values. See the clear is underscore. Okay, there are pf1 function. If you press f1, it's 1. All these you need not remember. Instead, you can use this copybook. That's what is followed in projects. That's a standard. So program becomes more easy. So this is a simple program, but this is more than enough for even for a fresher or even senior also.